All right, let's take a look at lesson 13 here. A scientist is growing single crystal diamonds in the laboratory using a standard process and a new process. The scientist wants to know which process causes the diamonds to grow faster. The mean growth rate for 20 diamonds grown using the standard process is zero point 0.7 micrometers per hour. The growth rate for 20 diamonds grown using the new process is 1.2 micrometers per hour. The scientist uses simulations to get a randomization distribution to determine if the results happen by chance. The randomization distribution is displayed in the histogram. Does the process used seem to have an effect on the growth rate? Or is the random assignment to groups a reasonable explanation for the difference? So, in other words, is this new process really having an effect? Well, let's first take a look at the difference. So, we know that the new process had a mean of 1.2, and the standard process had a mean of 0.7. So 1.2 minus zero point 0.7 is 0.5. That's your difference. Okay. Now, the randomization distribution, this histogram right here, actually is a result of all of the simulations. It's a result of the differences. And if you look here, when they did their simulations, most of their differences were around zero, between negative 0.05 and positive 0.05. We're around here. Okay. 0.5 is way the heck over here. Okay. Notice none of them had a difference. It's much, much higher than anything found in the simulation. So to answer the question, and I'm going to answer this verbally, so make sure you listen. Does the process used seem to have an effect on the growth rate? The answer is yes. The answer is yes. The new process does have an effect on the growth rate. And the reason is because the difference of 0.05 is way higher than anything found in the simulation. That is the reason why. Okay. If the mean growth rate for 20 diamonds grown using the new process had been 0.71 micrometers per hour, what would your answer be now? So, in other words, instead of 1.2 with the new process, if the new process was 0.71 instead, would my answer change? Well, 0.71 minus zero point 0.7 is a difference of 0.01. That is a much smaller difference. And if I take a look at the histogram here, okay, 0.01, use a different color. 0.01 is going to be like in here somewhere, okay? It's going to be in there. Notice a lot more have a difference around 0.01. So it actually fits with the histogram. Whereas the previous one, where I had a difference of 0.05, that was way higher than anything found in the histogram. So if my new process was 0.71 instead of 1.2, would my answer change? That is what number 2 is asking. I'm going to once again give you the answer verbally. What would your answer be now? So remember, the original question was, does the process used seem to have an effect on the growth rate? Okay. When the new process was 1.2, the answer was yes. Well, now when the new process is 0.71, the answer is now going to be no. So my answer would change. What would your answer be now? The answer would be no, the new process does not seem to have an effect on the growth rate. And the reason being is because the difference of 0.01 falls within most of the differences in the histogram. Okay. So when my original difference was 0.5, it was way higher than anything found in the histogram. So therefore, it did have an effect. But when the difference is only 0.01, that actually fits with our histogram. Therefore, it does not have an effect. Okay. And that right here, that is it. That is it for lesson 13.